Hello everyone, this is Farhanaz Khan and my partners are Amin, Zaina, Salia and Karimdad. So the data structure that we had was by a skip list, which is a variant of the normal skip list that we know about, but its goal is to access bias data more efficiently than the normal one. So let's just get into how it works. So just like in a normal skip list, the nodes are arranged in a sorted order. But the thing that's different here is that each node is assigned a rank according to how recently it's been accessed. So for example, if I add a node in the list, it will get assigned rank 1, and all the other nodes, like their ranks will increase by 1. And then if I access a node in the list, it will get assigned rank 1 again, and all the nodes whose ranks were lesser than the rank of this node that I just accessed, their ranks will also increase by 1. So furthermore, conceptually, the nodes are divided into classes, and the number of classes is log n, and being the number of nodes present in the list. So each class will contain two I minus 1 nodes in the increasing rank order. So for example, node with a rank 1 will belong to class 1, and class 1 will only have one node. Then class 2 will have 2i minus 1, which is two nodes, and then and they will contain nodes with in an increasing rank order. So for example, node of rank 2 will belong to class 2, node of rank 3 will also belong to class 2, node of rank 4 will belong to class 3. And we also have number of levels, which is just the height, but it depends on the number of classes. It's not completely random as uh, in a real in a normal skip list. So let's just see how it works. So according to the number of nodes that we have 4 classes, and according to that, we have 7 levels. So in the lowest level, we will have all the nodes that belong to all these classes, and then in level 6, we will have nodes which necessarily belong to class 1, 2, and 3, and it can have nodes which belong to class 4. Um, and then in level 5, we necessarily have nodes which belong to class 1 and 2, but it can also have nodes from their classes, but we just have to maintain this order of classes. And then in the highest level, it's necessary that you have the node that belongs to class 1. In this way, we make sure that the nodes which have ranks which have lesser ranks can be accessed faster than the nodes which have higher ranks. So using this, we decided to create a storage management system, which will let you access files and delete them, and like it will suggest what files to delete according to according to which files you least recently accessed. And we changed our data structure in a way that it maintains a descending rank order. So we did so like it's very easy to implement it that way. So we just made sure that the node with the highest rank will have its height equal to the maximum height of the list, and all the other things are the same as what I just explained. And the higher the rank, the least recently the file has been used, and then it can be suggested for deletion, which means that they can be accessed in a faster time than files which are just recently used. So even though our data structure implements this problem in a very efficient way, it does search better than a normal skip list, but its maintaining cost is still very high. You have to make sure, like you have to increase the ranks every time a node is accessed or added. Uh, our implementation is definitely not perfect because we could not find many resources on it, and it wasn't even tested properly. So it can be improved a lot, but we still think that it's not going to be the most optimal solution for bias data problems. um, but it does its job better than a normal skip list. This is all for today. Thank you so much.